Alright, so today we're talking about 1.5, solving multi-step equations. So most of this should be review, for the most part, things you've learned in the past. We're just reviewing how to solve multi-step equations. Some of it might be a little fuzzy, so we're going to go ahead and go through this. So anytime you're looking to solve an equation, what you're really trying to do is you're trying to figure out what the variable should be that will make this equation true, so that 4 does equal 1 minus 8 times whatever v is plus 3. So basically what we do when we're trying to solve for v is we're trying to get it all by itself so that we can see what number it should be. So we're going to be following the rules of addition, subtraction, multiplication, division. We're going to be undoing steps, but before we do that, we need to make sure that we have simplified each side of the equation as much as we can. So over here, we just have a 4, so there's really not much going on there. On the other side, we have 1 minus 8b plus 3. Since 1 and 3 are both just numbers, we can go ahead and actually do that operation, 1 plus 3. So that would leave me with 4 equals 1 plus 3 is 4, and then minus 8b. Now on this side, 4 minus 8b, there's nothing else we can do because these are not like terms. 4 and 8b are not like terms because 8 has a v multiplied by it, but 4 doesn't. So now we're going to start undoing things. We always, since we're trying to get v by itself, we want to undo this to times 8. We want to undo this 4 out here. We always start with the plus or minus, everything that's in front, or furthest away from v, and then we move towards the things that are multiplied or divided by v. So what we're going to do is we're going to undo this 4. Now this 4 is out front, which means, since there's no sign in front of it, it means that's a positive 4. So in order to undo this 4, we're going to have to do the opposite. We're going to have to subtract 4. If we do it from this side of the equation, we have to keep the equation equal. So if we subtract 4 from this side, we also have to subtract 4 from this side, so that they'll still be equal. 4 minus 4 is 0. This one also goes to 0. And so all we're left with on this side is negative 8v. Now v is multiplied by negative 8. In order to undo multiply by negative 8, I'm going to do the opposite operation, which is divide by negative 8. But if I do it to one side, I have to do it to the other, right? The division sign, not the division sign, the equal sign is what divides the equation into two sides, right? So do it to each side. So 0 divided by negative 8 is 0. Negative 8 divided by negative 8 is 1, so that would just leave a v on this side. So v is equal to 0. Okay, that's our first example. Alright, let's try another one. Alright, so number 2 is negative 2r plus 7r equals negative 10. So again, we want to look at each side separately first and equal simplified. Negative 10 is just one number, so it's already simplified. But negative 2r plus 7r, we can combine those because they are like terms. So this is just the same as 7r's minus 2r's, which would be 5r's. Okay. So 5r equals negative 10. To undo times 5, we got to divide both sides by 5. That goes to a 1. So r equals negative 2. Okay. Alright, so on number 3, notice we have two terms on each side. We have 6 minus 6n on the left, negative 10 minus 4n on the right. But we can't simplify either one of these sides because 6 and 6n are not like terms, likewise 10 and negative 4n are not like terms. So there's nothing I can do on each individual side, so we're going to have to look across here. So I can either subtract 6 from both sides or add 10 to both sides to get the number parts together. It doesn't really matter which one. I like to keep things positive, so I'm going to add 10 to both sides here. So this becomes 16 minus 6n. That one goes to 0. Equals negative 4n. Now again, I could add 6n or 4n to both sides. It doesn't really matter which one. But because the numbers, the 16 is already over here, I do want to get the numbers separated from the ends. So I'm going to take and add the 6n to both sides. That one goes to 0, so 16 equals 2n. And now we can just get n by itself by undoing times 2 on both sides. So 8 equals n. Alright, so let's try number 4 here. Let's see. Alright, so m plus 7 equals 12 minus 5m plus n. Again, the first thing we will always want to do is look at each side individually and see if there's anything you can simplify. With m plus 7, there's nothing I can simplify. On the other side, 12 minus 5m plus 5, I can add negative 5m plus m because those are like terms. So negative 5m plus 1m would be negative 4m. Alright, now again, I need to get all the letters on one side, or all the terms with variables on one side, and all the numbers on the other side. It doesn't matter which one I start with, it doesn't matter which one, which side I start with, or if I start with variables or numbers, as long as I move them over. So that one's going to go to 0 and just leave the m on this side of the equal sign. On this side of the equal sign, 12 minus 7 is equal to 5, so that's 5 minus 4m. Okay, now the second step, I do want to get this plain number away from the numbers with variables. So that's why I'm going to add the 4m to both sides instead of like subtracting 1m from both sides. Okay, but again, you would get the same answer either order you did it in, either direction, like if I move the m over or the 4m over. So that becomes 5m, that goes to 0, so 5m equals 5. Divide both sides by 5, m equals 1. Alright, let's try something slightly different. So notice in this one that we have some parentheses here. So basically all those parentheses tell me is that everything inside the parentheses needs to be multiplied by this 3. So since I don't see anything between 3 and the parentheses, that means it's being multiplied. Because the parentheses are there, I know that I need to multiply everything inside the parentheses by that number. So this would just be 99 equals 8 times 3 is 24, so 24k, and 3 times negative 7 is negative 21. So now I need to get the numbers away from k. Remember, I always undo pluses and minuses before I undo multiplication or division. So I'm going to add 21 to both sides of the equation. So this would give me 120 equals 24k, and then just divide both sides by 24. So 120 divided by 24, yeah, so it is 5, so that's correct. Alright, so let's try another one. Number 6, so again, we're just distributing that 7 into the parentheses. So negative 84 equals 7 times negative 3 is negative 21, and then 7 times 3 is 21k. So, there's a k here, there's not a k here, so we would want to add this one. Add 21 to both sides. It would give me negative 63 equals 21k. Divide both sides by 21. Negative 3 in this case. Alright, let's move on to number 7. Okay, on number 7 we have a fraction. Notice that this fraction, 3/5, is multiplied by x. Alright, so whenever you multiply a fraction by a whole number, and x, we don't know what it is yet, but for all intents and purposes, it's a whole number. This is the same. I could rewrite this as 5 equals 3x over 5. So if there's just a number out to the side of a fraction, it's the same as if that number were on top of the fraction with, in this case, the 3. So 3x divided by 5 is the same as 5 times 3/5 x. So there are two operations happening to x right now. Okay, that's all a fraction really is x is being multiplied by 3, and it's also being divided by 5. So because it's being both multiplied by 3 and divided by 5, we need to undo both of those. So we can do them separately. We can do them one at a time, and the order doesn't matter. We can times both sides by 5 and then divide both sides by 3 to get rid of those. Or we can do them at the same time. We can take our little fraction 3/5 and we can flip it upside down. 3/5 times 5/3 is going to undo both of those at the same time. See, 5 over 5 becomes a 1, and 3 over 3 becomes a 1. But don't forget, anytime I do something to one side of the equation, I need to do it to the other side as well. So I have 5/3 times 5 on the left, and I just have x left on the right. So remember, if I have a whole number times a fraction, I'm really just multiplying the top by that whole number. So 5 times 5 on the top divided by 3. So x equals 25/3. Okay, so again, a fraction is really just two operations happening at once. So here I have n divided by 5. If I had a number on top with n, like a 3 or a 2, that means n is multiplied by that number divided by 5. In this case, since I don't see a number up there with n, I can say, well, n is multiplied by 1 and divided by 5. But that's really all a fraction is. In order to undo this divided by 5, remember we always undo pluses and minuses first before we undo times and divide. So we're trying to get that n by itself. Start with anything that's plus or minus, do that first, then move to the add or subtract, or to the multiply or divide. So I'm going to add 7 to both sides to make that a 0. So n over 5 equals 16. Then, in order to get rid of divided by 5, I need to multiply by 5. So that 5 over 5 becomes a 1 on this side. And then 16 times 5, that would be 50 plus 30, so that would be 80. Okay. Let's try number 9. So again, this really is just kind of review of things you've learned in the past. Trying to remember how to handle things in fractions. So on this one, we have 5n minus 15. That entire thing is divided by 2. So remember that division symbol does group this 5n minus 15 together. So in order to get inside that group and get anything away from n, first we've got to work on the stuff that's outside, like this divided by 2. So the first thing we want to do is undo divided by 2 by multiplying both sides of the equation by 2. So on this side, 2 times 50, that's just 100. On this side, 2 over 2 becomes a 1, and so I'm just left with 5n minus 15. So now it's really just a two-step equation. I'm going to undo the minus 15 by adding 15 to both sides. So I get 115 equals 5n. That becomes a 0, right? And then divide both sides by 5 to get that n all by itself. 5 goes into 115, so that would be 23 times. So 23 equals n. Alright. Okay. So number 10, I have similar to number 9, but now I have two different terms on the right-hand side and on the left-hand side. So the first thing I do want to do, though, is still, I want to get rid of that divided by 3. Now, if I decide that I want to get rid of divided by 3 by multiplying by 3, remember this stuff's grouped together, so I've got to multiply by 3 first. But if I multiply this side of the equation by 3, that means I've got to multiply this entire side of the equation by 3 as well. Okay, I can't just multiply one of the numbers on this side by 3. I have to multiply everything on that side by 3. So the 3 over 3 will cancel out, and I'm left with 5x minus 2 on the left-hand side. On the right-hand side, I have 3 times 10 minus 5x, so I need to distribute that 3 into the parentheses. So this would become 30 minus 15x. And then I would need to get my x's together on one side and the other numbers on the other side. So let's add 2 to both sides first. So that would be 5x equals 32 minus 15x. And then remember, I want to get the numbers that are plain numbers away from the numbers that have variables. So I want to move the 15x to this side instead of subtracting 5x from both sides, right? Technically, you would get the same answer. We'll just add more steps if you multiply it the other way. So 5x plus 15x, so that's 20x. Oops. And that one goes to 0. So we have 20x equals 32. So in order to get x by itself, we need to divide by 20. So x equals 32 over 20. We do want to reduce our fraction as much as possible. They're both divisible by 2, so let's just start by dividing them both by 2. So that will be reduced to 16 by 10. And it looks like they have another factor of 2 in there. So 16 divided by 2 is 8, and 10 divided by 2 is 5. So 8/5 would be our x. Alright. Number 11. So on this one we have some distributive property as well. Tongue-tying distributive property. But it's on both sides, so I'm going to have to do the distributive property on this side, and I'm also going to need to do it on this side before we can simplify anything else. So 2 times k is 2k. 2 times negative 7 is negative 14, and I have minus 4 there still. 5 times 1 is 5, and 5 times 5k would be 25k. So all I did is multiply everything in this set of parentheses by 2, and everything in this set of the parentheses by 5. And I've just got everything lined up here. Remember, we want to look at each side individually first to see what we can simplify. So this side, I can add the negative 14 and the negative 4. So negative 14 minus 4 more would be negative 18. On the other side, there's nothing I can combine because, again, we have non-like terms. We have a 5 and a 25k. So now we need to get all the k's on one side and all the numbers on the other. Remember, which one you decide to do first really does not matter, as long as you make sure to be careful with your adding and subtracting. So 25k minus 2k is 23k. We want to get the numbers away from k, so we're going to subtract 5. Excuse me, so negative 23 is equal to 23k. Divide both sides by 23. Negative 23 divided by positive 23 is negative 1. Negative 1. So that one k is equal to 1. Alright, well let's actually skip number 12. It's very similar to 11. Alright, so now we have some decimals in our problem. So nothing's changed here. The only thing that's different here is that we do have decimals, but the rules are all still the same. So I'm still just looking at each side to see what I can simplify. 5.11 plus 5.3n. I can't go ahead and add those because they're not like terms, because that one's multiplied by n. On the other side, I do have this n here, and I have a negative 6.2n here. Those are like terms, so I can combine those. Remember, if I don't see a number in front of the variable, it's like there's a 1 there. So this is like a 1n. So if I do 1n minus 6.2n, that's going to give me negative 5.2n. And then I've still got that plus 3.01. So all I've done is I've taken 1n and subtracted 6.2n's. If I take 1n minus 6.2n's, I get negative 5.2n's. So this side stays the same because there's nothing I can simplify over there yet. So now I need to get everything on the same side. So I'm going to go ahead, since this is a negative 5.2, I'm going to go ahead and add that to both sides. Remember, if it has an n or variable with it, you can only add it to terms that also have that. You do it to both sides of the equal sign, right? So 5.11 plus 5.3 plus 5.2 would be 10.5n equals 3.01. So now, in order to get n by itself, I'm going to undo this 5.11 out front, which is positive out front, right? So I would subtract 5.11 from both sides. So 10.5n equals 3.01 minus 5.11. I'm just going to use my calculator just to be careful on that one. Minus 5.11 is negative 2.1. And then go ahead and divide both sides by 10.5. So negative 2.1, then my calculator again, divided by 10.5 is equal to negative 0.2. Okay, so all the same rules apply, we just have some decimals in there. So don't let it intimidate you. Okay, so on number 14, again, we are going to look at each side separately first to see if we can combine anything. But we have some terms with R's and some without, and unfortunately there's none that we can do that with. I'm going to go ahead and add 7.62 to both sides of the equation on that one. Again, you could start with moving R's. It doesn't really matter. You'll get the same answer in the end as long as you're careful with your operations. That's going to go to 0, so I have 3.2R left on the left-hand side, equal to R, and then negative 7.4 plus 7.62, that would give me a plus 0.22. Now I'm going to go ahead and move my R over here. Remember, it's a 1R if I don't see a number in front of it. So 3.2R minus 1R is 2.2R equals 0.22. Divide both sides by 2.2, and R equals 0.22 divided by 2.2, which is just